So, hello and welcome, what feels like a bit still like the middle of the night. I'm very proud of you that you at least managed to make it in here. And I'm talking about today about a demo I did for the deadline last year, which was called 1K is no limit. So we're going to do this in 3 parts. The first part is I will give a bit of short recap of the hardware that has been used, because this is custom made. The second one is how I got the idea for the intro, a bit of a work style breakdown, and in the third part, we're going to do a bit of short teardown of the parts, so that I will explain where ideas came from and how things have been solved in a specific way. So, with the first part, let's start with the hardware. The hardware has a quite interesting history, because in June 2023, I was asked to do a talk about, or a bit earlier, I was asked to do a talk about the first home computers. So how the first machines came to be, like the Kim 1 and stuff like that, so the really early stuff. So the first time that people could buy a computer to run at home. So the focus there was on 6502-based machines, and I had the idea, maybe it would be fun to give people some first-hand experience by building a very simple machine using the 6502. At this time, then there was the Raspberry Pi. Pico has been used for a lot of gadgets within the retro scene. So, for example, it has been used as a replacement for RAM, because it was way cheaper than salvaging some old RAM. So then I was there, they had the machine in the middle, they had their Raspberry Pi Pico, and typically it was run by a 6502. And then I had the idea, the middleman, I don't need that, and I had an idea. So, I wanted to build a computer, more in the style of a toy for nerds, and less than a full-featured machine where you would like to do some word processing on, for example. I also had to do it in just 2 months to come up with some hardware that works. And the idea was to show that the 6502, so that people could learn about them, you could see the CPU in action. And it should be a very easy thing to do on all levels of what you do, which should be easy to solder, easy to understand, easy to expand. So easy was the main driving force there. And I had 2 milestones that I wanted to do. First, to run like an old computer. That turned to be out the Apple I. The second one was to run a diagnostic monitor so that you can learn about the CPU. This kind of machine then needs a name. And I'm using a Raspberry to run like an Apple. So I wanted to name it Lemon, because if life gives you lemon, make a computer out of it. Wonderful tagline. The downside is there was an Apple II clone called Lemon. So I had to come up with something else. And then I remembered my mother telling me about the German term Vogelbeeren. Don't eat those, they are poisonous. However, they are not poisonous, you just can't digest them. But I didn't use them, so I didn't eat them, but I played with them a lot. So I threw them around, squashed, stomped on them. As a kid, I had a lot of fun playing with old berries, so I had found my name. It was reflecting the machine perfectly. And all I then had to do is come up with a name that also English language people or native English people could pronounce. Vogelbeere would not really work, so I looked it up in the dictionary and came up with Sorbus, which is more like the biological name. But I really like the term. So this is what the machine looks like. Just 2 PCBs, each one with a processor, one with a microcontroller, put into a passive base plane, and that's the computer. That's it. Then I came up with a refined version to make it a bit cheaper, even more. And also, what I was doing there, I was really just following in the steps of how the first computers were built. First, they were built like really each component was, even the RAM was an own board. And now I just integrated it a bit higher, mostly for the reason that it is less solder work. So there's 64 less solder joints you've got to solder. And also it's a bit cheaper to produce because it's only 1 PCB, not 3. So after I accomplished all the goals that I had up till then, I wanted to build my own machine. And I called it Jam. For just another machine, also you can cook Sorbus into jam, and then you can eat it. So it was again, a fitting term that fits nice well. I took a look at the designs of machines like Apple I, VIC-20, how things worked, and came up with something that was quite working. We get to this soon in a bit of a detail. I also added some I/O registers. Most interesting is I've got something like about 6 megabyte, but only 4 are really usable as a hard disk. So I've got an internal drive, as I like to call it, that is implemented with the flash storage on the chip on the RP2040 that I'm using. Also, a design decision was to go for a CMOS CPU, so the 65SCO2 or better. I was excluding the old NMOS because I wanted to also not to stick to what everybody knows from the C64, VIC-20, Atari 8-bits, 2600, something like that. There were a few more instructions there. There are a few bugs less, which is also quite nice. And sticking to this, I would also be forcing the old dogs to learn at least a new variant of the old tricks. The architecture is a dual-core microcontroller. So one core is for the I/O responsible, so that for all the interaction stuff. Also, if you stop the machine, then it would handle some kind of freeze monitor, something like that. And the other one implements the real system, so handling the GPIO, implementing most of the I/O stuff there, also using this internal drive that I was stating. This leads to a problem. As you can see, this is the clock of this chip, and typically this should be even rectangles. So the lower side and the upper or lower face and upper face, they should be equal, and especially, at least they should be all have something like the same size on each side. But here you see I've got a longer one. This is where the check is performed if something is in the queue from the input. So this is what makes things for me now very hard on some details that I've got some very uneven timing that I have got to cope with. So, and if somebody is good with PO code of the RP2040 or 2350, please contact me. I need help desperately. So, my machine had a memory map that was borrowed with ideas from the C64, VIC-20, Apple I, Apple II, something like that. So it's very plain. Typically, everything that's not defined otherwise is RAM. This also is true for I/O, bytes in the I/O area, in the internal one that has no function. But typically, it's something like I've got 52K of RAM or 51K of RAM, 51, 52K. And the ROM, then the upper 8K is banked. And there's one bank with RAM, like you know from the C64, for example, and the other banks are ROM. One contains the kernel, one contains BASIC, one some supplemental routines. And the last page is defined what I call as BIOS, and it contains all the bank switching code. So when you copy this from ROM to RAM, you can also use all the stuff that you know from the kernel. So this then leads into that I've got just 3 routines that are addressable via a jump to subroutine. Char in, char out, and print immediate. And the print immediate has the function that it doesn't change any registers, even the processor state register, so you can print it in there with debugging. So that's also not a problem. So you can do a print for some debugging purposes and still it works. All other functions that I've got, like printing an 8 or 16-bit value in hex or decimal, those are all software interrupts that are happening. So as the processor documentation states that the break opcode has a parameter, I really implemented this. And as far as I've seen, I'm either the first or one of a very, very few. We need sound. So what I built there, I got lucky again. At one point, I figured out there is a guy a Frenetic, who implemented a SID replacement using a Raspberry Pi Pico. So all I now had to do is to adapt the user interface or the interface to the machine to an own system. And the basic idea is that I have a full page, so I can do 2 sits without any problems there. So that part is new, but the other part is exactly taken from the ZKick Pico. So Pranetic, thanks for offering me the code. For graphics, I went a different route. This is a now defunct website where they claim the first fantasy console. I think the term console is a bit exaggerated there. It is a very simple 6502-based machine, also just a subset, that you can have an assembler where you can write some code in, then you can press compile and run, and then you can see what you did running there. So it was a very simple machine, and that was 32 by 32 pixels using Commodore 64 colors. And I was thinking there, how about doing this in hardware? And I started figuring it out with it. I noticed that the position of the frame buffer that they had with 0200 was really against the design that I already had, where executables were starting at 400, so that wouldn't match. So I couldn't do a one-to-one re-implementation of that system, but I could really pick up off the whole idea. And once this state was done, then feature creep set in. I was thinking about, I can improve this. Instead of just sniffing the bus and copying what's in there for my frame buffer, I could sniff just the whole memory. So what I then can do is I can decide that there is an area in memory that should be displayed on the screen. And all of a sudden, that doesn't have to be exactly the size of the frame buffer. So I could do a background. If I can define some transparency, I can then have something like similar to a sprite that I can put on top. So this led then to this API that I've got to that chip. So I've got a source address what I can use. I've got my state of the start pixel of the frame buffer, which can be done in XY format. That has been proven to be the better one. There also is an addressing mode where I can start at pixel number 512. This would also work. But I really never required that. And I can decide the width and the height, and I can also do a line step of the source code, of the source material. So what I can do is I can define, for example, an image 256 by 128 pixels. This is half of the memory. But then I can do a cut out of 32 by 32 pixels and just run it around in memory, and so I can move along this huge image with no really any effort at all. And now let's come into a bit as an example to the design philosophy. I not really by intention, but I always found myself resembling the ideas of the 2600, to keep it as simple as possible and make it also the hardware as simple as possible, unless a very small implementation of a feature will prove some large quality of life improvement. So in this case you can see that this image here is mirrored to the right, this is mirrored downwards, and then mirrored then again for the last part. And I was thinking about how to implement this within the C code, and at one point I was we do it the 2600 way, we see if we can do it in software. And then I tried to figure out how hard it would be to write some code that mirrors the pixel just on the 6502. And it has proven to be rather easy. So I said, okay, I don't need to implement this in hardware. I can do it in software. So keep it simple. And also it's more fun to experience how you can do this. Now as a recap, have I enough hardware for a demo? So I've got my base system, just works. I've got my sound, which is a clone of a SID, so even a stereo SID works well. And I've got graphics, 32 by 64, a bit improved. So it's by far not feature complete. There are so many things I still like to do with this platform and implement it. Bug-free. you've seen the timing diagram. This still gives me headaches. But it's definitely enough to do a demo. So, at one point, I decided to do a real demo on this platform. So, when going to Evoke, I went there with the idea, if I can code a keyframes effect there, then I can do definitely a full demo for a deadline, which was 7 weeks after Evoke. So I intended, okay, I will do nothing big, just something like 3 minutes. Keyframes will then be my first milestone, and if everything works out, every other step would be then another milestone that I define. So I did some concept studies then. So I did the keyframes effect already. I was thinking about, okay, I want to do a rotor, I want to do some 3D stars, a plasma, twister, the ball blazer effect, tunnel, all stuff like that. And this was just things that I was thinking I could do this and put it on a sheet for later, what I could do. Then I got to think, okay, we've got to do some storytelling arc, let's put it that way. What I've got is 40,000, 4K of colors. Like the Amiga, I also got 1K of LEDs, and I'm a huge fan of 1K is no limit by Losso, by the demo that he did almost a decade ago, or even more than a decade ago. And I was deciding, let's surprise Losso with yet another re-implementation of his demo. So, and the man fits nicely. This is 16 by 16 pixels, so I've got a 32 by 32 pixel screen. It's good real estate. So, and from the rest of the idea, okay, now let's take a look at the old school effects, and like I mentioned before, and see what we can implement them using the LEDs. The music at the Evoke, when I noticed that I could do the keyframes bars that would be working, I was immediately running to the best musician that I know for demo scening, Skyrunner, and asked him if you want to participate in a little demo for my own hardware build. It's nothing big, just 3 minutes. You get a dual SID that you can work on. And this only he noticed later that he has got way more RAM than he usually has in other productions. However, the downside is it turned out to be 8 minutes. Skyrunner, I'm sorry. So I also asked him to give us a slide with his point of view. So the 8 minutes really for him resulted into some time pressure. And he did work his typical way that he does, staring at the effects until he gets an idea that goes along nicely. And also he had then this guideline that we need the no limits theme in there, which was also helping. Of course, you need good transitions. I also was doing some transitions within from one demo effect to another, at least at the beginning, at the end not so much. There is a part where we re-implemented lemmings, visually just. At this point he knew he wanted to have the title theme in there. And he was also very pleased that he could have more memory than just the typical 4K that a C64 production would allow him to use. And we had a last minute, we had to fix a problem with the instruments that would resulting in the distributed zip file not being played correctly while on the hardware it would be working out. And I think if he summed it up very nicely, it seemed to have worked out. No criticism on PUE. So now that I had the idea that I wanted to do this demo, I was thinking about how to do this. And at work, we adopted some working style that was called Agile. So within a specific time frame, which is called typically a sprint, you deliver some kind of useful result. So I think, yeah, that is something that I can also do. However, my sprint was just one coding session, typically an evening or maybe an afternoon on the weekend, something like this. And the results were, I would consider it done when I had something like a concept for a demo part, would improve a demo part, would integrate it, would do a scheduler, something like this, or a tool that I require for converting some graphics, all of them, or even something like pixeling some greeting slide or so. And at the end of the day, there was always something I was happy about. Even there were 1 or 2 effects that didn't really work out, at least I was then at the point that I could state, there were, yep. So there was a place where when something didn't really work out, so something like a demo effect wouldn't work out as expected, I still had some closure there, so I could state, okay, this wasn't working out, but now I've learned enough maybe to know how to do it the right way. So it was really keeping the motivation high. And also I will be going about some details about this when we go on the parts breakdown. So, effects breakdown. Stop. Demo time. So, starting, this is just the interface that you get. You've got a file browser where we can load the demo, and now everything is happening here. Yep. Oh, now let's go to the parts breakdown so that you know now seen the parts. So, starting with a welcome screen, I did something like this also on the 2600. Every of my demos start with some small Atari logo flying in. I wanted to do something else in here. Anybody recognize the ping that was played there? Please raise your hand. That was ripped out of a C64 tool called XDOS Disk Doctor 2. I was using that as a kid a lot to manipulate my floppy disks, and every time it was playing the ping, and it was a nice ping, and I wanted to have it in there. So, when impersonating an Amiga, there are three things that are a must. Here's number one, the kickstart hand. I repixeled that myself, also for the emulation, this 6502 ASM. There was an implementation done there, but I didn't really want to ask if I could use the graphics, and also I thought I could do it a bit better than him. So I decided to go for that. Also, then I came up with a workbench, and those was some pre-calculation animation that the original intro did, the 1K intro did. I don't calculate anything yet, but it should look the same. And finally, some kudos to Frankie, who was definitely the fastest one on just coming up with the colors flashing on from black to white to gray. At the way he goes, that's Amiga, that's Amiga. So he's the fastest one recognizing Amiga. And I also told him that I was telling this. He's not selling stuff out there, so he couldn't be in here. He was saying, if I'm the best at something, that's poor. So then we had this re-implementation of lossless. 1K is no limit, but this was really just the epicycler. And this is how life is. I wanted to surprise him with this demo. I'm very early at deadline. I sit there, put all my stuff in there. 10 minutes later, Losso comes in. Hey, nice to see you, and sits wrecked night beside me. And I'm really there, shit, and I need to do some debugging. Music isn't fully integrated, so I need to do stuff there. And at one point, I decided that let's do something like a compromise. I was showing him the demo up to that part, so that he also then knew he should keep away and not like that. And he would then get the rest of the demo, which is also very Amiga themed as well. And he was very moved by the thing that he's gotten there. That was a wonderful thing for him to watch. So, smooth transition. So here I've got still the man, but the background of the next, and I was really something like sitting there hinting out, okay, this raster is something that is so familiar to everyone from the demo scene who has also then been a bit on taking a look into the history, or if it was quoted, it's typically also with this background. So you see, this turns into an Amiga board. Of course it does. This is the must number 2 you have when you want to do something impersonating Amiga. You have to put an Amiga ball in there. I think this is law. So also the shadow was done like in the original, not just exactly, but I had my shadow in there like in the original. And also this was a good example on working with this sprint attitude that I had in there. The first version of the Amiga ball used something like 2K just for the pre-calculated graphics that I did on the PC. However, later on, I realized I don't want to waste 2K of memory just for this ball. So I was wondering what I would do in pre-calculation, or could do, and what I should do with could calculate on the machine on itself, with the 6502. So with the squashing of the pixels there, I had a pre-calculated table for this. For the rest, this was all then calculated on the 6502, and due to this, the whole demo was then something more like a page excluding the table for the squashing and the subroutine for the squashing. So it was then that's gotten very nice, and also the squashing, maybe I could reuse it later. Then this trailblazer effect, where you have the illusion of moving up to something and the stuff rising out. Please, somebody can give me the mathematics about foreshortening. I was looking at it, a whole Saturday morning was wasted on trying to figure out the mathematics to find some documentation, some YouTube video. Everybody was just doing it the graphical way if you want to paint something or to draw something. Then it was explained how you do it. And I could have used this to figure out the mathematics, but at one point I was, fuck you, I just do it by rule of thumb. Should be. Also a bit of a problem is, those are all 16 brightness or 15 brightness levels that I've got, because black isn't really brightness. So, and that's all that I've got, and still most of the colors, especially in the brighter parts, they look exactly the same. So this is one of the downsides when going for the LEDs. Then I wanted to have something to explain something. Originally, I was thinking about doing something like an explanation for every part, so that you would have a guide that would guide you through. But for most of the other parts, there wasn't really something catchy that I could put in there, and this would really just stretch out the demo. So I just stick to 2 parts. So the first one, or to 2 times where I was using this. The first one was, I had to quote Logicoma, Ferris of Logicoma, for a man walks into some bars. He did an implementation, if I remember correctly, for the Mega Drive with Kefren's bars. And this is something that I came up when I told a colleague what I was doing with those bars. And he looked it up on the internet and came figured out, hey, look, there's something. And it's also a nice catch, and I was really laughing when I saw this one. I was, okay, this I must go in. Logicoma gets a greeting for that, so wonderful, everything's good. And I really want to have this one in, so that we can really see the man walking into some bars. So it was really, typically the Kefren's effect is coded that you have to do it line by line and add something new as you draw the next line. What I did, I was just drawing the biggest rectangle, then the second biggest, and so on. I just was drawing them over top of one of each other. So what typically is an illusion was the real thing in this place. And by walking through the bars, I had to paint the man in between there, and then continue painting of the 4 little rectangles. So, 3D stars. That was also something, I wanted to have 3D stars in there, and I also had a very nice idea on how to implement them. Because everything you see on here is just a line from the center to the outside. And what you see is just a single pixel being drawn on those lines. So, and it's I added a position mapping from 256 positions, so that I've got typical the range of a byte, just to the 16 positions that I've got on the screen there. And so, and it was not linear mapped, but I think roughly logarithmical, so that it appears when they get to the outside that they will be faster. But nevertheless, what you see is just line drawing from the center to each of one of the corner button or outside buttons here. That's it. The rings. So this was rather late at the end, because this was replacing another implementation that wasn't really good. And what I really did there was just drawing a picture of a circle and just cutting out the top left half, because the rest could be mirrored. I already had implemented this, so it was a nice thing to do. And this is then just color palette animation with a nice color palettes. So the effect that it was replacing was a tunnel, because I wanted to do a better tunnel. Yeah, and then after, I had a nice chat afterwards, about I really liked the optical illusion with the color rings. That was meant to be a tunnel. Oops. So now it's official, I suck at coding tunnels. I'm also thinking TRSI wants to make me a t-shirt out of that. Greetings. Greetings, I've got a problem with coding greetings because I want to put them in the right light, in a very nice light. Pun intended. The problem is typically most of the demos that I've done in the past were something like there was not enough space for doing some green, something like that. So it was all that. So this time I wanted to do it really right, and we almost spent half of the binary just for the graphical data for all the logos that you've seen. And also what I did is when something is moving, there were 2 DMAs that were triggered, one of the old picture going out and one of the new picture going in. So I didn't have to do anything in software, they were just in memory, and everything was working. So also thanks to Titus, who pixeled most of those images. I just did a few of them. This controversial slide, this space for rent. When I was doing this, I was sure if you do the greetings, just remembering the people that you met and that you really wanted to greet, not keeping a list, maintaining a list over time, you will forget someone. So I put in this placeholder for last-minute additions. The problem was, last minute was really last minute. There was no time to put anything in for last-minute greetings that I've forgotten. For example, TRBL. Sorry, guys. So, however, the timing of the music was dependent on the length or on the number of slides that were going through. So I had to also to keep this slide in. And I also thought then at the end, screw it. It's a nice gag. And this is the part now where I really wanted to have the explanation in there, because only in 2024 I learned about one of the first, now would call it demo effects, and the effect that it had on real life. Because in 1976, this was a demo that was running in a store on Fifth Avenue, was causing a traffic jam because people were walking by, taking a look. Oh, what's happening there? I haven't seen this before. Cars were passing by, wondering what those people were staring at, also stopping. So they had a traffic jam. And the police came up then, and they had to make sure that they're going to get this one dissolved somehow. So they couldn't find the owner of the shop. No mobile phones. So they picked out, but they could figure out the landlord. And they just told him, yeah, pull the plug. So he just turned down the whole electricity for the shop, and then the traffic jam dissolved. You can really look this up in Wikipedia, for example, if you look for the Dazzler from Kromenko. And this then is this kaleidoscope effect. The original was done in 64 by 64 pixels with this it was some of the very first graphics cards for the Altair 8800. So I only had 32 by 32 pixels, so I had to strip it down a bit. The color palettes differ, but not so much as I expected. And also the original was done on the 8080, since for the Altair 8800, and not on a MOS 6502 like I did. This code would also really work on an old machine. Then, plasma effect. This is one of the things that I really find interesting to do. And also this is about really improving step by step. The original was just integer math. Then I came up with fixed point math as something like that. Then I noticed that if I just switch parameters during the demo running, then the transition would be too hard. So I came up with a way to soften that transition. And the whole thing started, really the idea, I knew that I wanted to code that, so the idea already had. But the day I started was when I was sitting with a colleague for a burger after work. And we were discussing that I already wanted to take some days off to do some coding, but really couldn't. And I was like, yeah, but something like a plasma effect I can do in a day. And then I got home, started coding, and at the end of that day, I was really sending him a short video of a short plasma animation already. So I proved I can do it in a day, and it doesn't even have to be a day off. It can also be just at the end of a workday. Rotor. This is one of the most fun things that I had coding this demo. I was sitting there, I wanted to have a rotor. Nothing was really looking well. I was going with some static images or some static color, something like that. And at one point I was, okay, now I take a look. Every time something changes, so if I'm going for a new line that will be drawn, if I'm going just for a new pixel on that line to be drawn, I will change the color every time. Sometimes a bit more, but I will really touch the color register every time I'm going to drawing a pixel, and not really knowing what I would expect. I was just trying things out. And then I saw this, and I was, hands off, it can't be done any better. And something like 2 days later, I was thinking about maybe I could do it with slight tweaking, and everything I tried to make it better made it worse, so it stayed that way. The twister this was a very basic implementation. I wanted to have this one a bit better. So also what you see, this should be really not the same color. Here you can see it a bit, that it's getting a bit darker, but nevertheless it wasn't really working out. I also wanted maybe to have something like an image wrapped around this, but this was also something in the final week, and at one point I stated, things will get too complicated, so I'm sticking to this. And then the credits, the lemmings. In one of my 2600 demos, I was having the Man of Impossible mission running along, which was some nice achievement to get done, because on the C64 they were using 3 sprites, but I only had 2, so it was a really challenging thing to do. And I also wanted to have something similar like that. And I was, yeah, of course, Amiga, lemmings. Lemmings is one of the typical Amiga things to do. But I was also thinking about how to do the walking ride that it really looks good. I didn't want to have them look like they were marching or something like that. And so I came up with the idea, okay, just animation frame 1, animation frame 2, animation frame 3, and every frame increment by 1. And it worked out very well. 2 months ago, I was sawing a backpack on a demo party with 16 by 16 LEDs where 2 lemmings were walking along. And they were using just the same animation phase for both. And they really looked like marching. And I said, they did it wrong, I did it right, thank you. And of course, somewhere I wanted to have something like a closing thing. And the idea really was to play around a bit with a man for the ending and have it turning around, because I already had the routines for shortening, stuffing the pixels, and I only had used it for the ball. So it was already in there and was figuring out. First I was doing then the whole spin, that it just turns like a coin, and then I was something like a bit of twisting. It was just playing around, it sticked, and it was working out like that. And of course, the 3 rules that you've got when impersonating Amiga, the third thing that you've got to do, you have to close with a Guru screen. However, I really could just print out Guru, trying to come up with some Guru meditation. It would have looked awful. So, short aftermath. The whole demo is slightly less than 42 kilobytes. Originally, I wanted to have it packed with the Exomizer and do a port of the Exomizer that it supports my architecture. However, I realized it would be a lot of effort for not really much gain. So I decided I can do it uncompressed, then I do it uncompressed. Also, the frame buffer typically I put at the end of the normal RAM, but I moved it at the beginning of the RAM that is under the ROM, just to have more space for the music in there. So, however, this wasn't really required, but it was to be safe. And once the conversion was working, because also moving all the data around was a bit tricky. There was some things that weren't working at the beginning. So I was something like, now it's working, I won't change it back for no reason. And in the discussions afterwards, you could have done it a bit quicker. This was one of the feedbacks that I've gotten. And typically I would have proved this person, yes, you are right, but those are LEDs. I like to stare at them. People like to stare at them. And when I tried to shorten some of the effects, it was really missing like, no, I wanted to have to watch this a bit longer. And it was really something like, so the pacing, even though it was a bit slow, not so many changes for the effects, it still felt like the good timing to have. Also, one of the things that were then left on the cutting floor, as you can tell, I wanted also to have the menu at the beginning stating what you want to run, that you can also pick a specific effect and then let it run endlessly. Maybe I will do a version 1.1 of this demo and put it in there, but I'm not sure, because now I've got other things to do, like fixing this damn timing problem. So everything you've got there is open source. So the whole hardware is open source. The firmware for this is open source. Everything is available. I also took some time to, I also originally had the documentation as just some part of Markdown files. And at one point I figured out that there's a nice tool which is called MKDocs, where you can use Markdown files for your documentation, and they just will do a binding on your loose sheets of information. So there were still some things missing, I added them, and now I've got a nice documentation site. The entry point there is Jam, so it's already the machine. If you go top level, then you see also about the hardware, stuff like that. Something where I did a detection on several 6502 variants, so the NMOS versus CMOS and the CMOS version among themselves, or something like that. It's all in there, it's all documented, so it's quite a nice thing to take a look at. And of course, the demo source code is also available. This is not on GitHub, but on my private Git account, because I don't think there will be much participation in that and fixing bugs or so. So, I'm done. Thanks for listening. And it looks like we have something like 5 minutes for a question or so. Please wait for the mic.
Short question, is this LED panel available?
This is also described in the documentation. What I did, on AliExpress, you can buy those NeoPixel or WS2812 in a format of 16 by 16. So those are just 4 16 by 16 panels, 2 across, 2 down. And you can concatenate them. So it's really just one line of 1024 pixels. And there's a translation matrix that converts then the pixel position to the position in the queue there.
Thank you.
Any other questions? Well, then again, thanks for listening to some old man rambling. Have a lot of fun at the revision here, and I will be also watching then the upcoming talk. See you. Thanks.